Hello and welcome back to my channel. In this video I am going to cover different types of trigonometric identities. So basically there are three different types of identities, that is reciprocal identities, quotient identities and Pythagorean identities. Now before I could start with these identities, we will see what are the applications of trigonometric identities. So where are they used? Trigonometric identities are quite popular in civil, electrical and mechanical engineering field, and you can find a lot of applications in music industries as well as architectural industries. Now let me take the music industry for example. Playing of guitar or playing of violin. So if you are listening to music, next time you can just check the equalizer and see there are some kind of patterns generated. The waves look somewhat this way. This is just an example I am showing you. So probably they are going to look somewhat this way. So this is how a violin, for example, the beats are the frequency have been generated. Now the trigonometric identities basically revolve around sine, cos and tan. So sine, if you see the graph, it looks somewhat like a wave in the ocean. And if you see the cos, it looks almost like a sine wave but a bit different. And then comes the tan waves, which look somewhat this way. So what happens is these three types of waves, or there are different ones for the cosine, for the cosec, for the secant and for the cotangent also, the graphs are there. So if you relate the graphs to this frequency generated by the violin, you can find out what exactly kind of beats need to be generated, making use of these identities. Now if you see for the architectural industries, for example, they are building a kind of a building and they have to know at what angle it needs to be made. For example, you can take Burj Khalifa. You can see the way it has been formed. So for example, this is the shape. This shape has been designed using the trigonometric identities, a small part of it when they were designing it, because they had to know at what angle the base, some floors had to be made so that it could withstand the rest of the floors. So you can see these small things add on to bigger things. So let us start with the trigonometric identities in learning in details now. Let me just get rid of all of this. Alright, so let us start with the first one, which is called as reciprocal identities. In my previous video on Introduction to Trigonometry, I had explained you that there are three basic trigonometric ratios and each one has its own reciprocal. So I'm going to explain the same over here. The first and foremost important trigonometric ratio is the sine theta. So the reciprocal of sine theta is going to be 1 over cosec theta. In some books, instead of writing cosec, they have written the term as CSC. So you can use CSC or cosec, both are same. Now, if in some examples cosec theta is given, then obviously its reciprocal is going to be 1 over sine theta. So this is the first pair you have to remember. Now coming to the second pair, the second pair is cos theta. So the reciprocal of cos theta is 1 over sec theta. Now similarly, if in examples you see sec theta, you can obviously write it as 1 over cos theta. This is the second pair. Finally, you have third one, that is tan theta. So the reciprocal of tan theta is going to be 1 over cot theta. Similarly, if you have cot theta given, you can always write its reciprocal, which is 1 over tan theta. So these are the three pairs which tells you about the reciprocal identities. The reciprocal of sine theta is cosec, the reciprocal of cos theta is sec theta, and reciprocal of tan theta is 1 over cot theta. Now these are your reciprocal identities. The next type of trigonometric identity is quotient identities. I have already written over here. Tan theta is given as sine theta over cos theta, and cot theta, since it is the reciprocal of tan theta, could be written as cos theta over sine theta. These are the other two quotient identities you have to remember. So 6 over here and 2 over here. So till now you have 8 identities learned. Now let us start solving some examples on these two identities. So this question says verify sine theta times cot theta times sec theta is equal to 1. Verify means you have to make the left hand side equal to the right hand side. So the right hand side is 1 and the left hand side is sine theta times cot theta times sec theta. Now to start with the left hand side. We will keep on solving it till we get it equal to 1. So here we have sine theta. Sine theta is in its simplest form, so we can just write it as sine theta over here. Now cot theta, I can use the quotient identity and write it as cos theta over sine theta. As I have explained in the previous identity. So quotient identities, cot theta can be written as cos theta over sine theta. That is the same thing. I have done it over here. Now, and sec theta, I am going to use the reciprocal identity over here. Sec theta, I will write it as 1 over cos theta. Now sine theta, no need to use the reciprocal identity. My advice is, if any of the questions come, try to get them in terms of sine, cos and tan. Do not change them to their reciprocal identities like cosec, sec and cot. So with that, we will see if any of the terms will get cancelled. Sine theta and sine theta gets divided. Cos theta and cos theta gets divided. So we have 1 over 1. So we get the answer as 1. This is what is equal to your RHS. So this is how we solve the examples. Let us look at the next question. It's given as sine x times cosec x over cot x equal to tan x. This is again you have to verify. So verify in the sense your left hand side should be equal to the right hand side. So we will again take here left hand side because this looks more complicated than the right hand side. So let us write it as sine x times cosec x. So cosec x, I can write it as 1 over sine x. So I'm going to write it 1 over sine x, whole thing divided by cot x. So I will write cot x the same way it is. I'm not going to use any identity here. Now you can see that sine x from here and sine x from here gets divided. Hence we get the answer as 1 over cot x. And 1 over cot x is the reciprocal of tan x. So we can directly write 1 over cot x as tan x, which is equal to the RHS. So once you know the identities, it becomes really easy to judge what you have to use and what you not have to use. As you can see, for the cot x, I did not use the quotient identity because it was unnecessary, because in the RHS you saw the tan x, and cot x and tan x relationship is the reciprocal identity. So I have used the reciprocal identity over here, not the quotient identity. These are another set of examples where you have to solve the given question. Here you do not have to verify that left hand side is equal to right hand side. Now, as you can look at the first question, it is given as tan theta times sec theta times sine theta. And as I mentioned earlier, keep the tan, sine and cos the way they are. Do not go to change them to their reciprocal function, but change their reciprocal functions into the sine, cos and tan form. Now as you can see, tan is given and sine is given, so I am not going to change them, so it's going to remain as tan theta and sine theta. But sec theta is obviously a reciprocal function of cos theta, so I'm going to change the sec theta as 1 over cos theta. The next thing you can do is keep the tan theta the way it is, and 1 times sine theta is sine theta, and it becomes sine theta over cos theta. Now sine theta over cos theta is the quotient identity, where sine theta over cos theta is equal to, it's given here as tan theta. So in place of sine theta over cos theta, I'm going to replace it with tan theta. So let me write the tan theta here. It becomes tan theta times tan theta. And tan theta times tan theta can be written as tan squared theta. This is your final answer, and this is the way you have to solve it. Let us look at the next question. This is also been asked to solve. So you have to solve cos theta times cosec theta over tan theta. Now cos theta and tan theta, let us keep it the same way. We will not change it. So cos theta over tan theta, and cosec theta is the reciprocal of sine. So in place of cosec theta, I am going to write it as 1 over sine theta. Next, I am going to multiply cos theta with 1 and rearrange the term as cos theta over sine theta multiplied with 1 over tan theta. So if there is a multiplication, obviously you can rearrange the terms this way. The next thing we can do is cos theta over sine theta is a quotient identity, and it's a quotient identity of cot theta. So we will replace it with cot theta times 1 over tan theta. And you can either change the cot to tan, or you can change the 1 over tan to cot. So in this case, I'm just going to change the 1 over tan to cot. So you can get the answer as cot theta. And this is the reciprocal identity. 1 over tan theta is again cot theta. So cot theta times cot theta gives you cot square theta. If the answer is being asked in terms of tan, then what you can do here is, after this step, change the cot theta to tan theta using reciprocal identity. So it becomes 1 over tan theta times 1 over tan theta. So you get it as 1 over tan square theta. So both the answers are acceptable. This is how you solve it. Now the third type of identity is called as Pythagorean identity. It is called as a Pythagorean identity because it resembles the Pythagoras theorem, where C is the hypotenuse and A and B are the two legs of a right-angled triangle. And we can write the Pythagoras theorem for this as A square plus B square is equal to C square. So let us relate this Pythagorean theorem to the trigonometric Pythagorean identities. The first Pythagorean identity and the most important one is given as sine square theta plus cos square theta is equal to 1. So as you can see, sine square theta resembles A square, cos square theta is same as B square, and 1 we can also write it as 1 square, but 1 square is again 1. So 1 square resembles the hypotenuse, which is C square. So for time being, let us just remove that 1 square because 1 square is 1 itself. Now what we are going to do is we can rearrange this given identity as sine square theta is equal to 1 minus cos square theta. Similarly, we can also rearrange this as cos square theta is equal to 1 minus sine square theta. So this is very important to remember. These two are the rearrangements and this is the main identity. Now the next identity is given as 1 plus tan square theta is equal to sec square theta. Again, this main identity can be rearranged as 1 equals sec square theta minus tan square theta by taking the tan square theta on this side, or we can also write it as tan square theta is equal to sec square theta minus 1. So these two are the rearrangements and this is the main identity. So in some of the examples you can find that sec square theta minus tan square theta, you will be able to find them. So you have to understand that sec square theta minus tan square theta, it is a part of an identity and that is equal to 1. So you can replace their sec square theta minus tan square theta by 1. So you will understand it in details when we start solving the examples. Now let me write down the final Pythagorean identity, that is 1 plus cot square theta is equal to cosec square theta. So here again you can rearrange it as 1 equal to cosec square theta minus, you can take the plus cos square theta on this side and it becomes minus cot square theta. This is the first rearrangement, and the next one is going to be cot square theta is equal to cosec square theta minus 1. So you don't have to remember the rearrangements, you have to just remember the main identities. That should be more than enough to solve the examples. So let us start quickly with solving the examples. I have written the identities again here for an easy reference. These are reciprocal identities, these are quotient identities, and these are Pythagorean identities. So let us start with the first one. Prove that sine theta times cosec theta minus sine theta is equal to cos square theta. So you have to prove that the left hand side is equal to the right hand side and use the one which looks more complicated. So obviously this is more complicated than the right hand side. So let me write down the left hand side first. So left hand side is given as sine theta times cosec theta minus sine theta. Now let us start solving this. Remember one thing, if sine, cos and tan are given, no need to change them into their reciprocal identities, which is cosec, cot and sec. Remember one thing, if in the question there is sine, cos and tan, do not change them. Change their reciprocal identities like cosec, cot and sec in terms of sine, cos and tan. So there is a sine theta, I will keep it the same way, I'm not going to change it. So sine theta, and cosec theta I can write it as 1 over sine theta. Let me put the bracket, and minus sine theta. Now after doing this, your basic mathematical operations begin. That is, here I am going to put denominator as 1 and I am going to take a common LCM. So here it's going to be 1 times, and here it's going to be sine theta, and here also it's going to be sine theta. So let us start solving it. It's going to be sine theta, which is outside the bracket, and inside the bracket it's going to be 1 over sine theta, because sine theta times 1 is sine theta itself, minus sine theta times sine theta gives you sine square theta, over 1 times sine theta gives you sine theta. After this, we are just going to simplify it further. The sine theta remains the same, and inside the bracket, since the denominators are same, we are just going to combine the numerators. So it becomes 1 minus sine square theta over sine theta. This is a multiplication. Now here, this sine theta cancels with this sine theta because there is a multiplication, and sine theta and sine theta will divide each other. So we are left with 1 minus sine square theta. If you see a square in the given answer which you have got, think about the Pythagorean identities, because the square comes only in the Pythagorean identities. It doesn't come in your reciprocal identities or quotient identities. So the Pythagorean identity you can see here, it is sine square theta plus cos square theta equal to 1. So there is a sine square theta here. So using the first Pythagorean identity, which is sine square theta plus cos square theta is equal to 1. I can take the sine square theta on that side, so it becomes cos square theta is equal to 1 minus sine square theta. Now the main identity, I have rearranged it and written it this way. So you can see we had got the answer as 1 minus sine square. So 1 minus sine square is equal to cos square theta. So 1 minus sine square theta is equal to cos square theta, and hence proved, because they had told us to show that whatever question we had got is equal to cos square theta, and we have got it as cos square theta. Now let us look at the next question. These further questions are a combination of all the 3 identities you have learned. So prove the identity 1 minus sine theta is equal to cos square theta over 1 plus sine theta. So again we have to prove that LHS is equal to RHS. Now in this case, the more complicated one or the more terms, you can find it in the RHS. So I'm going to use the RHS and write it as, so RHS is equal to cos square theta over 1 plus sine theta. And since there is a square and this is your first Pythagorean identity, and cos square theta we had already seen here above that it is 1 minus sine square theta. So we are going to write here as 1 minus sine square theta over 1 plus sine theta. Here in trigonometric identities examples, we have to also make use of algebraic identities. For example, here in the numerator you can see that this is of the form a square minus b square, the numerator. It's like 1 square minus sine square. And in the algebraic identities, a square minus b square is given as a plus b times a minus b. So here if it is 1 square minus sine square theta, we can always use the algebraic identity and write it as 1 plus sine theta times it with 1 minus sine theta. So I'm going to split the numerator and write it as 1 plus sine theta and times 1 minus sine theta over the denominator, which is 1 plus sine theta. Now we can cancel the terms which are common at the numerator and the denominator, and we are left with 1 minus sine theta in the numerator, and this is the LHS they had told us to show. 1 minus sine theta, 1 minus sine theta. So you can always use LHS to solve, or you can use RHS also. Use the one where there are more terms. Let us look at this next interesting question. This is again a proof question where they have given prove the identity sec x minus tan x times sin x is equal to 1 over sec x. As I mentioned, try to change the reciprocal identities, the sec, the cosec and the cot in terms of sine, cos and tan. So here the sec, I'm going to use the LHS here because there are more terms in the LHS. So the sec x, I can write it as 1 over cos x minus, I'm going to change the tan in terms of cos and sine. So if there are terms which have sine and cos and there is a tan, change the tan to cos and sine. So tan, I'm going to change it as sine x over cos x using the quotient identity into sine x. So this is the LHS. Now as you can see, the denominators are same. Here it is cos x and here also it is cos x. So we can combine the denominators. The LCM is same, so it is going to be cos x, and I am going to combine the numerators. So it's going to be 1 minus sine square x. And 1 minus sine square x. Again you can remember sine square x comes in the Pythagorean identity. So sine square x can be written as 1 minus cos square x, or cos square x can be written as 1 minus sine square x. So since we have 1 minus sine square x over here, that is equivalent to your cos square x over cos x. So now 1 cos square x goes from the numerator and 1 goes from the denominator, and what remains is cos x, which is equal to your RHS. So let us see if it had asked us to find cos x. They want us to write it in terms of reciprocal identity, 1 over sec x. And we know that the reciprocal identity of cos x is 1 over sec x. So this is going to be your RHS as proved. So these are similar kind of questions I have compiled, and this also has all the three identities. Let us start with this now. Cosec square x times tan square x should minus 1 should be equal to tan square x. So you have to prove. Again, this is LHS and this is RHS. So we are going to take the LHS because there are more terms. So LHS is given as cosec square x. Cosec square x is a reciprocal of sine square. So I'm going to write it as 1 over sine square x times, since there is a sine here, I will change the tan square x in terms of sine and cos. So it is sine square x over cos square x using the quotient identity minus 1. This is the remaining term we write here. Now, as we can see, the sine square x and the sine square x divides each other, and we are left with 1 over cos square x minus 1, and 1 over cos square x, it's a reciprocal of sec square x, so we can write it as sec square x minus 1. Now sec square x is again a Pythagorean identity, in which the main identity was 1 plus tan square x was equal to sec square x. So it has become a rearrangement of this main identity, that is 1 has gone over here, so it becomes tan square x is equal to sec square x minus 1. That's why here sec square x is equal to tan square x using this identity. So let us see what was the RHS to be proved. Yes, so this was the RHS, which was to prove it as tan square x, and we have got the RHS. The previous ones were the prove questions where you had to prove that LHS is equal to RHS. Now this is a question where you have to solve the given question. So let us see how we can solve this. It's given as tan theta minus sec square theta over tan theta. So the first thing which comes to mind is to take the LCM. So here I'm going to multiply it with tan theta, and here also I'm going to multiply with tan theta, because here tan theta was there, and here I'm going to multiply with 1, and here I'm going to multiply with 1. Now tan theta times tan theta becomes tan square theta over tan theta minus, here it is sec square theta times 1 gives you sec square theta over tan theta times 1 gives you tan theta. So since the denominators are same, I will combine the denominator and write it as tan theta, and the numerators also gets combined and you write it as tan square theta minus sec square theta. Again, we know that this is a third identity of the Pythagorean identity, which was 1 plus tan square theta is equal to sec square theta. So you can rearrange this identity because it is given as tan square minus sec square. What we are going to do is we are going to take the sec square on this side and it becomes 1 plus tan square theta minus sec square theta is equal to 0. Since in the numerator we need only tan square theta minus sec square theta, we'll send this 1 on the other side. So it becomes tan square theta minus sec square theta is equal to -1. So we get here the answer as -1 over tan theta, or we can also write it as a reciprocal identity and write it as minus cot theta. Both the answers are acceptable. So it's very important for you to memorize these identities, and you can see here how we are going to rearrange the main identities. So it becomes really easy to solve these kind of examples. Now this is the last question which we will be solving in this video. Now you have to verify again that this LHS is equal to this RHS. So if you want to give a try, you can pause the video and try it yourself before I could start. So you can see here this is the left hand side and this is the right hand side, and so I am going to use the RHS over here. So RHS is equal to 1 plus cos square theta. Now cos square and sec square are reciprocal of each other. So what I can do here is I can write it as 1 plus, in place of cos I can write it as 1 over sec square theta, because they are both reciprocal identities. Now I can use the basic mathematical operation, that is taking the common LCM. Here I can multiply with sec square theta, and here you can multiply with sec square theta, and you will get here as 1 times sec square theta is sec square theta, and here it is plus 1 over the denominators become same, which is sec square theta. So you will be getting the LHS directly over here using the RHS as well. So you can see the LHS was this 1 plus sec square theta over sec square theta, which is same as sec square theta plus 1 over sec square theta. Now if you want me to show you for the LHS, what we can do here is, let me take the LHS then and prove it equal to RHS. So this is given as 1 plus sec square theta over sec square theta. This is your LHS. So I'm going to separate out the denominator first and write it as 1 over sec square theta, and this becomes 1 plus sec square theta. So I've just separated out the denominator. That's it. Now 1 over sec square theta is written as cos square theta using the reciprocal identity, and here sec square can be written as 1 over cos square. So where you are changing all the sec square terms to cos square. Using the LCM again, this is times 1. I'll multiply here with cos square theta, and here I'm going to multiply with cos square theta, and here I'm going to multiply with 1 and here with 1. So we get it as cos square theta, and denominators are same now, so the numerators will combine and it will become 1 plus cos square theta over cos square theta, and here we can just cancel off the numerator and the denominator, and you're left with 1 plus cos square theta, which was the RHS. 1 plus cos square theta, 1 plus cos square theta. So it depends on you whether you want to change it from LHS to RHS or RHS to LHS. So it's up to you. So either choose the LHS which are having more terms or choose the RHS which are having more terms. So if you're liking the videos, please like, share and subscribe to my channel. And this video was on the basic examples of trigonometric identities. I will be uploading another video which will be on advanced trigonometric identities. And thanks for watching.